let's look at some more examples. The cube root of x squared y cubed. Now, x squared cannot come out, and the reason is 2 is smaller than 3. This power of 2 here, 2 is the power, it is smaller than the index right here, which is an index of 3. So x squared cannot come out. Now, y cubed, it can come out. They're equal, the index and the power are the same, so some things can happen. Namely, what we do, remember the law of exponents, 3, or by the rules of radicals, I should say, 3 divided by 3 is 1. So that comes out as y to the 1. So the cube root of x squared y cubed is just y times the cube root of x squared. The y cubed come out as y, but the x squared cannot come out at all. So there's that. Let's do something more interesting. What if I do the cube root of x squared y to the 6th? Well, what happens is x squared can't come out, of course, but let's go over here to the right first. X squared can't come out. Here's what we do. We do 6 divided by 3, okay, and that's 2. So we get y to the power of 2 times the cube root of x squared, the term that could not come out. Now, and the reason it can't come out is because 2 is too small. It has nothing to do with what type of letter we're using or anything like that. No. It's just that 2 is too small. But anyway, it would be... sorry about that. It's my scroller's being difficult. And again, in a similar fashion, if I do the cube root of x squared y to the 30th, that's going... Let me go over here. That's going to be... we do 30 divided by 3 is 10, so it's y to the 10th times the cube root of x squared. Now, one thing I didn't comment on earlier is I didn't go back to the left. This is 0. Since these two guys are equal, this guy equals this guy, the subtraction of the 2 is 0. And likewise here, the subtraction of the 2 is 0 because they're equal. We established a minute ago that this guy equals this guy, so if we subtract the 2, we get 0. And again, we're assuming all variables are positive. All the variables, x, y, z, whatever you see is positive. And since these two are equal, this is 0. Since these two are equal, this is 0. You know, so on and so forth. Well, anyway, that's... so we get that. And these two are equal, so this is 0. Now let's do a more interesting one. What if x is well behaved? We get like the cube root of x to the 21 y to the 30th. Well, 21 divided by 3 is 7. 30 divided by 3 is 10. So we get x to the 7th times y to the 10th. Notice there is no radical left over. Everybody came out clean, so there's no radical left over. There would only be the number 1 left inside the radical, but that's just any radical of 1 is 1 itself. And if you multiply anybody by 1 itself, you just get that anybody. So there's no radical left over here. And so if we subtract these two, for the same reasons, we'd get 0. But anyway, there's that. And now, down here I made it more interesting. I stuck in a coefficient of 125. It's a perfect cube. 125, by the way, is 5 cubed. Or 5 times 5 times 5. So this, for the cube root, you go ahead, you take the 125 out as 5, because it's a coefficient. You do the honest-to-goodness cube root of 125 and you get 5. Now, the exponents you divide by 3 and you get, like you did before, and you get x to the 7th y to the 10. Okay. Now, in the next example, what I do is I get a little sneaky. I use something that's not a perfect cube, but a multiple of a perfect cube. I use the number 250. Now, notice, let's go to the right first. We need to do this first. 150 can be thought of as 2 times 125. So I've got 250 times x to the 21 times y to the 30th. That's just 2 times 125 times x to the 21 times y to the 30. But notice that 125 comes out as 5. That x to the 21 comes out as x to the 7. That y to the 30th comes out as y to the 10th. But the 2 cannot come out. So for the 2, he's stuck. So I have to do times the cube root of 2. Notice there's that messy cube root that's left over, but we have to have it because that 2 could not come outside. Now, What if I wanted to cause some trouble in another way, though? What if I wanted to do, and I won't bother doing this whole equals zero business. What if, allow me to type, and forgive me while I type. My best ideas always occur later, it seems. But let's say that I have the 250 again, but I'm going to cause trouble in a different way. What if I do x to the 23 and y, let's just say to the power of 31? Now notice, yeah, it's true, 23 is bigger than 3, and 31 is bigger than 3, but they're not clean multiples of 3, so that's a little bit of trouble there. So we need to filter. We need to sort of shake the dirt off the plant. So here's what I mean by that. So we need to so that equals the cube root of. Now let's shake off 250. What's the biggest perfect cube that will go into 250? Namely 125. And then times. Now x to the 23rd, since we're doing the cube root, what's the biggest multiple of 3 that is still smaller than 23? Well, that would be 21. So I do times x raised to the power of 21. And then times, and now for 31, for y, what is the biggest power of y? Excuse me, what is the biggest multiple of 3 that is smaller than 31? And that is 30. So I do that for y. So for x, I do the biggest multiple of 3 that is smaller than 23, which is 21. And for y, I do the biggest multiple of 3 that is smaller than 31, and that's 30. But now don't forget, though, we can't just ignore our other terms. There's a 2 there, because that 125 used to be 250. And there's an x to the power of 2, or x squared, because notice we have x to the 21, but we used to have x to the 23, so we're missing a couple of multiplicative x's, so we need this times x squared here, because 21 plus 2 would bring me back to 23. And also, don't forget, we need a y to the 1 power, which is just y itself. Again, we originally had 31, so we need to add 30 to an understood 1 here and get 31. Now, so there's that. We have to furnish what. So notice that we have this guy on one hand. Let's separate. I don't really need parentheses here, guys, arithmetically or algebraically, but I'm going to put them anyway. And notice these times signs are silly, so let me just get rid of these pesky times signs. They're silly. I just put them there for clarity. You know, it was cool, but we're done with them now. And then I don't really have to have this middle times sign, but I will need to do that. Now let's do that. And let's do that. And let's do that. And okay. Notice, let's write it like this. This is a more helpful notation. The other was correct, but this is more helpful. So I've got this guy, which is a bunch of perfect cubes stuck together by multiplication, times the other junk stuck together by multiplication, stuff that's not perfect cubes. So what I do is I insert my equal sign, and I've got so it's a cube root of. Now, well, first off, before we even do that, what can we take out? That 125 comes out as a 5. That x to the 21 comes out as x to the 7th. And that y to the 30th comes out as y to the 10th. Like that. Now, just to avoid messiness, let's put that times sign there. Remember, you take the honest cube root of 125, and whereas on the other hand, you divide the exponents by 3, because we're doing the cube root. Guys, if we were doing the fourth root, we'd divide all the exponents by 4, and we'd take the honest fourth root of whatever coefficient we could. But we're doing the third root, or the cube root here, so we do 3. But anyway, now notice that, see this 2x squared y here? He's stuck. None of those guys can come out. The 2 can't come out, the x squared can't come out, and the y can't come out. So that term is stuck. 2x squared y, it's a term of variables. Each variable is stuck. Keep in mind 2x squared y is really just 2 times x times x times y. So, but anyway, nothing can come out. So there's that. And indeed, the power of 2 here, the understood power of 1 here, and 2 and 1 are both smaller than the index of 3. Okay, so there's that. And let me get that in there, and let's save this. Guys, that'll be all for this video. Let's move on to the next video. Thank you, and I'll see you on the next video.